I am trying to ping from this PCA. I am saying that ping to 10.0.0.3. Okay, so when I'm pinging any device for the first time, what happens is the first and foremost thing that the PC does is it creates an incomplete ICMP packet. Why the ICMP packet is incomplete is because in the ICMP packet it will have the uh, data, ping data, whatever echo your ICMP packet will be there. So you will have an ICMP header and you will have the IP header along with it. So in the ICMP header, you will have what type of ping it is, whether it is a ping request, ping reply. We will see into the ICMP header later. Okay. So you will have an ICMP header. So this ICMP header will have like this is a ping request. So it will have certain codes and all. Okay. So we'll look into that codes. Then you will have the IP header, that is your layer 2 header, layer 3 header, and then you will have the layer 2 header, that is your Ethernet header. Okay, so in the IP header, you will have the sub details, that is your source IP address and the destination IP. Okay, then you will have the source MAC and the destination MAC. Okay, so these things has to be filled. Now, when I speak about the IP header when it is attached, so the source IP address, I know I'm pinging from 10.1. Okay. So the IP address, source IP address will be 10.0.0.1 and destination IP address is 10.0.0.3 because I'm pinging to this address. I don't know whether this device exists in the network or not, but I want to ping this device. But to send this data to the device, we not only require an IP address, we also require the MAC address at layer 2 to send an ICMP packet successfully. A source IP address along with the source and destination MAC address is also required. So source MAC address, any which ways I know it is A, that is my PC, but destination MAC address is unknown. So the ICMP packet remains incomplete. This is the ICMP packet. Now this ICMP packet remains what? It remains incomplete, and without the destination MAC address, data won't go out. Okay. Now to fill these details, what does the PC does is the PC will first check its ARP cache, ARP cache or ARP table. Okay. It will check ARP table to know, do I know 10.0.0.3? Okay. Let me show you the ARP table. How does it look like? This is my command prompt. So if you have your access to your command prompt, so what you will say? You will say ARP hyphen A. So this will list out the ARP table. Can you see this? So this is the IP address and its associated MAC addresses. I would have communicated, this is my gateway probably, okay, or my router. And I want to reach the gateway, means every time I'm sending the data towards the gateway. So I know the physical MAC address of my gateway. So this was learned dynamically. There are some IP addresses and its associated MAC addresses are there that are statically there. So ARP entries are two types, static and dynamic. Static will be permanent, means once it is entered, it is there until unless I manually removed. Okay. Whereas dynamic is the one that is automatically learned and this keeps refreshing. Understood? So this is the ARP table, which will have the IP address and its associated MAC address along with it. So now the PC will check, do I know 10.0.0.3? Is it there in my ARP table? Is there any associated MAC address to this? In case if the entry is found in the ARP table, it will directly fill this information here and the ICMP packet will transmit it. In case if the device MAC address is not found in the ARP table, then the PC will do what? It will generate an ARP. Okay. After this, the PC will do binary AND. What is binary AND? In the binary AND, the PC will find whether these two devices are in the same network or subnet. If they belong to the same network or the same subnet. Okay. So in case if they are not in the same subnet, then the process is different. Consider currently we are doing for packet flow within a network. Okay. Single network we are talking about. Then we will look about packet flow multiple between two networks. Now it does binary AND to find if these two IP addresses belong to the same network. So what is the CIDR value or what is the subnet mask? Based on that it is going to compare. So if it is /8, it will compare the first 8 bits of the source address. 10.0.0.1 is the source address, 10.0.0.1 is the 0.3 is the destination address. So first 8 bits will be compared according to the CIDR value. So when I see that, okay, the first 8 bits are same, so they fall under the same network. So if it falls in the same network, then the PC will generate a ARP request. The ARP request will be generated to find 10.0.0.3, which says who is 10.0.0.3. Now, what does the ARP request contains? So when I speak about an ARP request, you will have an ARP header. If you saw, okay, this is the ARP request. So it will have two headers. One is the, hold on. It'll have two headers. One is the ARP header and other one is the Ethernet header. Okay, so this is the ARP request message. The ARP request message contains one information, that is opcode, which will be 1 for a request message. For request, it will be 1, and for response, it will be, for reply, it will be, ARP reply, it will be 2. So when you see a 1 in the opcode or operational code or whatever you call it as, okay, so this operational code will be 1 for a ARP request when the request is going out. Then you will have the sender IP, sender MAC, and you call it as target in case of ARP terms. Okay, you don't call it as destination IP address, it is target IP address and target MAC address. Now, source IP address is 10.1 according to the ICMP packet 10.0.0.1. Source MAC is A. Target IP address is 10.0.0.3. This is what I'm looking for. Okay, and target MAC is unknown, so it will be set to zeros initially. All 12 zeros. Okay, 12, because you have 12 digits in a MAC address, correct? Yes or no? Hexadecimal value. Then Ethernet header, it will be source MAC address and destination MAC address. Now, source MAC address is A. Oh, now destination MAC address defines, it will tell the switch what to do with this ARP packet. Now, because this ARP has to be sent to all the devices in the network, okay, because I want to know where is 10.3, correct? So how many of our devices are there? This is 10.4, this is 10.5. So all devices has to receive this information. So I have to do a broadcast. So the broadcast MAC address in the destination MAC address will be all FFs. Okay. All 12 FFs will be given in the broadcast. Now this address will define, or it will tell the Ethernet device or the Ethernet switch that it should be sent as a broadcast because I'm looking for this IP address. Okay, so the ARP request will go. All the devices will receive. They will see, is it this address? So all the devices will drop this message. Okay, they will drop this packet. They will not respond back to the ARP reply. Only the device that is 10.3 will respond back. Okay, so when the device responds back, so you will see a ARP reply. ARP reply will come where the opcode will be 2 this time. Source IP, source MAC, target IP, target MAC. Your ARP request will be a broadcast communication. Okay. Now, source IP, source MAC, target IP, target MAC address. Then you have the Ethernet header, source MAC address, and destination MAC address. Now, source IP is 10.0.0.3. This is the one that is replying back, correct? So this is the source now. A is the destination. Source MAC address is C. So it is sharing its MAC address details now. Target IP is 10.0.0.1 and target MAC address is A, the one from where it came. Source MAC address is C, target MAC address is, destination MAC address is A. ARP request is a broadcast, whereas an ARP reply is a unicast, one-to-one. Okay, now When the reply comes, the switch will see that, okay, it has to go to PCA. Switches maintain a table called as the MAC address table. Let me tell you about that also. A switch maintains a table called as a MAC address table, or it is also called as the CAM table. Very technically, you call it as CAM table, content addressable memory. Make a note of this, okay? So it will have the details like which VLAN it is connected to, then what is the MAC address of the device, and which port it is, okay, how it was learned, type, and the port number. So let's suppose this port number 0/1, like we have switches will have 0/1, 0/2 if you have seen, 0/3, 0/4, and 0/5. This is D and E. So it'll have VLAN 1 by default, everybody will be on VLAN 1. So it will say that, okay, MAC address 0A:00 is dynamically it was learned and it is connected on port 0/1, fast Ethernet 0/1. 0B is connected to fast Ethernet 0/2. 0C is connected to F0/3. 0D is connected to F0/4. And 0E is connected to F0/5. Like this, it will have the association. So when the reply comes back, it would have noted that when this PC sent the ARP request, it would have compared that on port number 0/1, I got a communication from PCA. So it would have learned A's MAC address initially. So now the PC knows that, okay, A is connected on port number 0/1. So this reply will go only to A. It will not go to everybody. It will be a unicast communication. How a switch is able to do unicast? Because if it knows the MAC address with its associated port, it will do the unicast. In case if the switch, the address is a broadcast address, the switch will do a broadcast. If a address is a destination address is a multicast, it will do a multicast. Understood? Okay. Now the ARP reply comes, the PC gets to know what is the MAC address of this PC 10.0.0.3. So it will update its ARP cache first. So ARP request is sent. Then you will get the ARP reply saying that, okay, 10.0.0.3 PC's MAC address is C. And then it will update its ARP cache so that in future, whenever I want to communicate to 10.3, its details is there in my ARP table. From now on, no ARP will take place. ARP will take place only for the first communication. You saw that the first packet was getting request timed out, correct? Whenever you're pinging from a router, the first one was a dot, then you see the exclamatory marks because ARP communication is going on and the first packet gets timed out. Okay. So now the ARP cache is updated with the details. Done. So now the PC gets to know what is the MAC address, and this ICMP packet, an incomplete ICMP packet, will be complete now by filling the details of C. Now the ICMP packet travels the network, and this time it will be a unicast because I know the source IP, destination IP, source MAC, and destination MAC, everything. So packet will go only directly from the source PC to the destination PC. ICMP will be a one-on-one communication. Clear? Any doubts with this packet flow? We will discuss about packet flow. So this is about the ARP, how ARP communication works. Okay, within the network. We'll have to speak about the packet flow. First finish this, then we will speak about the other network. Understood how ARP works? Now, one more thing, very important. ARP broadcast, the ARP request will be broadcasted only if they both belong to the same network. Okay, ARP is a broadcast and every network is a separate. Every network or subnet or VLAN is what? Subnetwork or a VLAN. These are separate broadcast domains, correct? What do you mean by broadcast domain? A broadcast cannot cross this domain, correct or not? It should be within the domain. So whenever I want to communicate outside my network, what is my last boundary? What is the boundary of my network? Whenever I want to communicate outside my network, what I have to do? Where will I reach?
Router.
So that will be your default gateway. Default gateway or the router, whatever you call it as. So whenever you have a packet, when you do this binary and you find that they are not in the same network, then you will forward the request towards the gateway. Okay, the PC will not do a ARP request within the network. ARP broadcast will not take place here. Clear? Okay. Okay. Note this down, then I'll explain you that about the two networks.